Hey there, this is going to be a walkthrough for the ions and octets rule assignment. So let's get going. You should have this opened up on your screen. You're going to need your periodic table for this. So remember that the number of valence electrons is told to us by the column on the periodic table. So you should have your colored periodic table handy, or you can use this one that I gave you. But you are going to need to know that the column tells you the number of valence electrons, and if the column number is greater than 13, you're going to need to ignore the 1 in front and just go with the number that's left. All right, so let's dive right in. So first, we're going to start with cesium. All right, cesium is right here on the periodic table, number 55. It's in the first column. This is the alkali metals. Since it's in the first column, that means it gives me one valence electron. Cesium will have one valence electron. So what you're going to do is you're going to double click on this number bar, and it's going to open up a place where you can edit. So first, we're going to go with the smiley face, and we're going to drag it and drop it right above the number 1 because, like we said before, cesium has one valence electron. I'm going to hit save and close. So this is visual, and it's meant to show you that the number of valence electrons is either closer to an empty shell or a full shell. And if you remember from the lecture notes that we had in class, that the goal of every atom is to get to an empty shell or to get to a full shell. If it goes to an empty shell, it's going to give away its electrons. So I'm going to write that one here. Give. Please forgive my bad handwriting. It's hard to do this with the mouse. So if it gives away electrons, it's going to give away the electrons to get to 0. So if the number is less than 4, it's going to give electrons away to get to 0, which is going to be positive. If the number is greater than 4, like over here, it's going to take electrons in order to get to 8. And you might be asking why 8? 8 is a full shell, so that means that the shell is full and it can be stable when the shell is full. So if it takes electrons, think of it like you're taking something away from somebody, and that's normally a bad thing. So negative. So when we get back to this, all right, we're going to walk through these questions, and it should be very logical step by step. So first, it's going to ask you, is the smiley face closer to 0 or 8, and by how many? So obviously, the smiley face is closest to 0, and it's closest to 0 by 1. So it goes one spot to get to 0. So I'm going to type in 0 by 1. Right, so then is the element going to give or take? So this is on the give side of the number line, so I'm going to write in give. How many? It's going to be the number of spaces you move to get to 0 or the number of spaces you move to get to 8. So since we've decided that cesium has 1, which is closest to 0, it's going to give that 1 away in order to get back to 0. So it's going to give away 1. And like I said, if it gives it away, that's going to be a positive charge. And it's going to be positive the number of electrons it gave away. So plus it gave away 1. So it'll be plus 1. And it's going to be the same if it gave away 2 or 3. It'd be plus 2 or 3. We're going to learn why that is next week. And then for the cation, anion, if you remember that funny joke that cations are positively charged because cats have paws. Get it? Haha, that's funny. I know. So cation will be your answer here. So that is step by step how you do each problem here. Now, this part for F can be a little tricky, so please pay close attention. So I'm going to take cesium here, CS, all right? And I'm going to go down to the periodic table that's on the last page. So follow me down to the last page. here. So this is where I'm at. So I'm going to place cesium on this table and then going to put the plus charge at the top of the column it's in, because everything in the family has the same valence electrons and it has the same charge. So I'm going to double click on this picture. I'm going to put a +1 in this box at the top because cesium was in the first column. Cesium was in the first column in the 6th row. All right, so if I go back here, look, column 1, row 6. So that's how I know where to put this blue box. Now, please copy and paste this blue box. This box up here is meant to be copy and pasted so you don't have to recreate a box every time. So I'm going to click Control C, then Control V to paste, and I'm going to move this down to correct location. So 1, 2, 3, 4, 5, 6. So now I'm going to type in CS for cesium. That's it. So I'm going to be doing this for every element that we do in the assignment above. So please keep that in mind that you're going to need to place every element in the assignment above on this table somewhere. All right, so my first part is +1 cesium. Hit save and close. You should see this pop up. Now I'm going to go back up to number 2. So for number 2, same deal. So I'm looking for beryllium. Beryllium is right here. So that is in the second column and the second box, or the second row, which is an alkali earth metal. So beryllium is what I'm looking at. Double click. It has 2 valence electrons because it is in the second column. So I'm going to place this here. Hit save and close. Okay, and now I'm going to answer these questions. So is the smiley face closer to 0 or 8? 0. 2. It's 2 away from 8. Is this element going to give or take electrons? Select the one above. If it's closer to 0, it's going to give. If it's closer to 8, it's going to take. So this is going to give electrons. It's going to give how many electrons? So it is 2 away. So 1, 2 to get to 0. So it's going to give away 2 electrons. All right, like we said, since it's giving, that's like a good thing. So think of it as a positive. And then how many electrons? 2. And just like before, anything that's a positive is going to be a cation. I have all the information that I need to go down and put this in the table. So beryllium is in the alkali earth metals in the second row. It has a +2 charge, and its symbol is Be. So I'm going to go all the way to the bottom, go back in here. So group 2 is right here. I'm going to put +2 in the box. If it doesn't fit like mine just did, that's fine. Or you can just kind of resize it so it does fit nicely in there, just like that. Copy and paste the blue box and move it to where beryllium is, which is right here. And then I'm going to type in the symbol, Be. And that's it. All right. So you're going to continue this all the way through the elements that I give you. Don't try to fill in the entire table. Okay. I've had students try to do that in the past and it gives me a headache. So only do the ones that are on this paper. So what I'm going to do now is I'm going to show you carbons, how to do carbon on this one. And then I'm going to show you one of the negative ones just so you're aware. Okay. So let's go back up. I'm going to skip to carbon, which is number 4. So the reason I'm skipping to this one is because it's a little tricky. Carbon isn't either or. All right, and I'll show you what I mean by that. So carbon is here, 14th column, the carbon family, and it's in the second row. So if I double click on this and I move this, all right, so if it's in the 14th column, remember drop the 1, which gives you 4. So I put this here, save and close. All right, if your maths is good, then you should realize that carbon is 4 away from 0 and also 4 away from 8. So it's kind of a predicament because it's neither or. It's neither one. So in the ones we've done before, it's obvious which one it's closer to, but carbon's smack dab in the middle. So let's answer it like that. Is the smiley face closer to 0 or 8? By how many? All right, neither. It's in the middle. Or you could just write it's in the middle. Next, is the element going to give or take electrons? And that is tricky. So that depends on what carbon bonds with. Now, that's complex chemistry that we're not going to get into in this class, the why of that. But essentially, it depends on which one wants the electrons more, carbon or the thing it bonds with. So it can do both. All right, so I'm going to do both here. How many electrons will this give or take? All right, since it's in the middle, all right, if it goes 1, 2, 3, 4, do that 1, 2, 3, 4, giving, it would give 4 here. But if it goes the other way, to 8 to become full, 1, 2, 3, 4, it could take electrons, and that would be negative. So kind of depends. So will it give or take electrons? All right, so how many? It will, either way, it's going to be 4. It's going to give or take 4. So the answer is 4. Now, what is the charge of this one? Okay, so if it gives away 4 electrons, it's going to become positive and be a cation. If it takes 4 electrons, it's going to be negative and become an anion. So this one depends. So I want you to do a plus/-4. Because it could do either one depending on what it bonds with. And will it be a cation or an anion? It depends on the situation that it's bonding in. So what you need to know here when we go down to the table below is that it's going to be ±4 is the charge in that column. So all the elements in the carbon family can either give or take away electrons. And carbon is a C. So I'm going to go all the way down to the bottom. Okay, so carbon is in the 14th column and the second row. All right, so we're going to go to the 14th column, which is right here. And remember, it's plus/-4. You can resize the box to make it fit. Carbon is the first one there. And remember, copy this blue box and paste it. Drag it over to the correct location and type in the symbol. All right, and that's what I'm looking for there. So that's why carbon's a little complicated, but it's also very useful for us as carbon-based life forms. It means it plays nice with a lot of elements. All right. Finally, I'm going to go through a negative one real quick. So, for example, let's look at iodine. All right. Iodine is going to be a negative ion, an anion. It has 7 valence electrons because it is in the 17th column. All right. If I go here, iodine is part of the halogens, and it's in the 17th column. So it is closer to 8. So you would type in 8, I1. Since it's closer to 8, remember, If it's closer to 8, it's going to take that many electrons to get to 8. So 7 needs 1 electron to get to 8. So it's going to take an electron. How many? 1. What is the charge? If it's taking, it's going to be minus however many it took. So minus 1, and that makes this an anion. Down to the bottom, and fill in that on the chart, putting a minus 1 up in the top column and putting iodine down where it goes on the periodic table. Once you are done with all of these, don't forget about the exit ticket here. All right, I know this sounds kind of tedious because you had to listen to me talk about it, but we did go over it in class. But once you get rolling, it does go pretty fast, and it's easy because you understand how it goes. But we're also going to be adding these charges to the periodic table. So if you have yours at home, you'll be ahead of the game if you can go ahead and add the numbers that are in the red boxes at the end to your chart. It'll put you ahead. All right. So think about this when you do it. What is the trend of charges on the periodic table? Look at all of them as you go. What are the positive in metals? Are the negatives non-metals? And please make sure you answer all of these. Do not forget about them. That is part of your grade. All right. So if you have any questions, please reach out to me and ask. But I do expect that you give this a good try before you throw up your hands and say, I don't know how. Okay. So please reach out to me, and hopefully this video helps.